MathKlik.
Mabuhay! What are equations in quadratic form? Can we solve equations in quadratic form the way we solve quadratic equations? This lesson will focus on solving equations in quadratic form. There are equations that may appear complicated, but when transformed into a more familiar equation form like the quadratic form, their solution can be easily done. To solve this equation with ease, try to express them in the form AF squared plus BF plus C is equal to 0, where F is an algebraic expression. Here are some examples of equations that are not quadratic but can be expressed in quadratic form. In the equation quantity x minus 1 squared minus 6 quantity x minus 1 plus 9 is equal to 0, if you will let f is equal to x minus 1, you will have f squared minus 6f plus 9 is equal to 0, which can be solved by factoring. In the equation x to the negative 2 minus 4x to the negative 1 plus 1 is equal to 0, letting f be equal to x to the negative 1 will transform the equation into f squared minus 4f plus 1 is equal to 0, which is easier to solve. Similarly, the equation x raised to 2/3 minus 2x raised to 1/3 plus 5 is equal to 0, which is equivalent to quantity x to the 1/3 square minus 2 quantity x to the 1/3 plus 5 is equal to 0 may be transformed into f squared minus 2f plus 5 is equal to 0 if we let f be equal to x to the 1/3. Let's take an example. Solve the equation x to the 4th minus 5x squared minus 6 is equal to 0. This equation is an example of a quadratic equation. Since this equation is of the 4th degree, we have to find 4 roots. Look at the 2nd degree term. If we let f is equal to x squared, the original equation can be transformed into f squared minus 5f minus 6 is equal to 0. Factor the quadratic trinomial and solve the resulting linear equations f minus 6 is equal to 0 and f plus 1 is equal to 0. The roots of the equation f squared minus 5f minus 6 is equal to 0 are 6 and negative 1. Let us use these f values to find the x values. Remember, f is equal to x squared. Replace f with 6. This gives us x is equal to square root of 6 and x is equal to negative square root of 6. Then, replace f with negative 1. This gives us x is equal to I and x is equal to negative I. Therefore, the 4 roots of x to the 4th minus 5x squared minus 6 is equal to 0 are square root of 6, negative square root of 6, I, and negative I. Here is another example. Solve the equation x to the negative 2 minus 4x to the negative 1 plus 1 is equal to 0. Note that the equation contains negative exponents. This equation can be rewritten as quantity x to the negative 1 squared minus 4 quantity x to the negative 1 plus 1 is equal to 0. We now have a lead. if we let g is equal to x to the negative 1, the equation can be transformed into g squared minus 4g plus 1 is equal to 0. The value of the discriminant of this quadratic equation is 12, which means that g squared minus 4g plus 1 is equal to 0 is not factorable. Let's now use the quadratic formula to solve this equation. The values of a, b, and c are 1, negative 4, and 1 respectively. The resulting values of g are 2 plus square root of 3 and 2 minus square root of 3. But wait, don't stop here. What we just derived are the roots of g squared minus 4g plus 1 is equal to 0 and not the roots of x to the negative 2 minus 4x to the negative 1 plus 1 is equal to 0. Now, since g is equal to x to the negative 1, first replace g with 2 plus square root of 3 and solve for x. This will give you x is equal to 2 minus square root of 3. Then replace g with 2 minus square root of 3. This will give you x is equal to 2 plus square root of 3. Therefore, the roots are 2 minus square root of 3 and 2 plus square root of 3. Now, try this. Solve the equation 6x to the negative 2 plus x to the negative 1 minus 1 is equal to 0. Here is a suggested solution. Therefore, the solutions are x is equal to 3 or x is equal to negative 2. Solve the equation quantity x plus 2 to the fourth minus 13 quantity x plus 2 squared plus 36 is equal to 0. Here is a suggested solution. Therefore, the values of x are negative 5, negative 4, 0, or 1. For more matitinik tips, just click MathKlik. And please, don't forget to subscribe and click the notification bell for our next video lesson. See ya!